Hello students, so far we have discussed about two or three congruency rules. Those are SAS congruency, ASA congruency and AAS congruency. Right, so in this video we will be basically discussing about the remaining two congruency criteria of triangle. Those are SSS congruency, that is side 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 congruency, and RHS congruency. And in the later videos we will be talking about isosceles triangles and some other rules. Okay, so let's first start with our SSS congruency criteria. So as you can see, in these are the two triangles. Let us name these. This side be P, right, this side be Q, and this side be R. And in the same manner, let us say this is A, this one is B, and this one is C. So clearly you can see that side PQ is equals to side AB, side QR is equals to side BC, and side RP is equals to side CA. Right, so you can see that three sides of two triangles are equal, so we can say that these two triangles are congruent. And by CPCT, right, as we discussed earlier about CPCT, that by CPCT their corresponding parts, that is this angle will be equals to this angle, and this angle will be equals to this angle, and our third angle will be equals to this angle of another triangle. Right, as we have studied that in CPCT, corresponding parts of congruent triangles are equal. If two triangles are congruent, then their corresponding parts will also be equal. Right, now move on to next congruency criteria, that is RHS congruency rule. Right, so for this rule it is important that the two triangles must be right angle. Right, so here in figure 7.3 you can see that. Let us again name these two triangles. So this one is side A, this one is side B, and this one is side C. And the same way, let us say this is side P, this is side Q, and this one is say R. So you can see that side BC is equals to side QR, side AC is equals to side PR, and angle B is equals to angle C. So RHS congruency rule stands for right angle, hypotenuse, and side. So for two triangles to be congruent by RHS rule, at first thing that is important is that one angle must be right angle, and these two triangles in these two triangles each 90-degree angle will be equal to another 90-degree of other triangle. Hypotenuse must also be equal. You can see this side is equals to this side, and this any other side, it can be this one, should be equal to this one, or this side should be equals to this side. Then by RHS congruency criteria we can say that these two triangles are congruent. So again, by CPCT we can clearly see that their corresponding parts will also be equal. That is, angle A will be equals to angle P, angle C will be equals to angle R. Now let us solve some questions based on these two rules. So first let us start with example 7. It is here given that AB is a line segment. Right, this A and B, this is a line segment, right? And P and Q are the 2 points which are opposite to this line segment AB, and such that uh, each of them is equidistant from point A and B. It means point P is equidistant, that is the length of point P from A is same as length of point P from B, right? And in the same way Q is also equidistant, right? That means this point A is having equal distance from Q, and point P is also having equal distance from Q. So we can say that AP is equals to PB, or AP equals to BP, and AQ is equals to BQ, right? So what here we will do is, what we have to prove is, show that the line PQ is perpendicular bisector of AB. We simply have to prove this, that side AC is equals to side BC, right? And that is what perpendicular bisector means. And one more thing that we have to prove is, this angle is 90°, right? We have to prove two things, right? One is perpendicular and other is bisector. For if we want to prove that this line PQ is perpendicular to AB, we have to prove that angle PCB or PCA is equals to 90°. And for bisector, we need to prove that AC is equals to BC, right? So let us now start. So here we will take triangle PAQ and triangle PBQ. So clearly in this triangle you can see that side PA, the side PA is equals to PB, this side AQ is equals to side BQ, and the side PQ is common in both two triangles. So we can say that this triangle is congruent. Now if these two triangles, that is PAQ and PPQ, if these two triangles are congruent, we can say that their corresponding parts will also be equal, which means this angle will be equals to this angle, and this angle will be equals to this angle. Alright, and this angle PAQ will be equals to angle PPQ, right? So now again let us consider this triangle PAC, that is this one, this triangle and this triangle, right? So in these two triangles you can see that side AP is equals to side PB, this side is equals to this side, and this angle was equals to this angle. We have proved this by CPCT, and side PC is common in both. So we can say that triangle APC, right? Triangle APC is congruent to triangle BPC, right? And hence angle PAC will be equals to triangle PCB. Why? The reason that you will mention here is that this is equal by CPCT, right? So triangle PAC, sorry, PCA, I'm really sorry for this, angle PCA, this angle will be equals to this angle. Also one thing here you can see is this line segment, at line segment AB we are having another line. So if we draw a line, suppose this is our given line segment, and if we draw another line, so it will divide this line segment into two angles, right? And this sum of these two angles, this angle and this angle, will be equals to 180°, right? And clearly we have seen that this our angle PCA is equals to angle PCB. That's why if we add these two, what we will get is 90° for the value of PCA, right? So far, so till now we have proved that uh, angle PCA is equal to angle PCB, which is equals to 90°. So first part, that is, we have to prove that it is perpendicular. We have proved this thing. Now we'll prove that it also bisects. AB, right? So again we will see that as we have proved earlier that this triangle is congruent to this triangle. So again by CPCT, this side will be equals to this side, right? This will be equal by CPCT. Why? Because these two triangles are congruent, and therefore their corresponding parts, that is side AC, will be equals to side BC. So we have proved that this line segment PQ is bisecting line segment AB perpendicularly. And let us move on to next example. Here and example 8, we are given that P is a point which is equidistant from two lines L and M. P is a point which is equidistant from line L and M. That means the length of line PB will be equals to PC, at which is intersecting at point A. We have to show that the line AP bisects the angle between them. That means we have to show that this line AP is also bisecting the angle formed when these two lines L and M are intersecting each other, right? For this we will first consider triangle PAB, small one, PAB, and triangle PAC, right? So in this we can see that side PB is equals to side PC, and this angle is also given, it is 90 degree in both, and side PA is common in both, which is also the hypotenuse. So we can say that by RHS congruency these two triangles are congruent, so their corresponding parts will also be equal, which means this angle will be equals to this angle. That is what we needed to prove in this question. So let us now go through the first question of exercise 7.3. In this question we are given that triangle ABC and triangle DBC, these are the two isosceles triangle which are formed on the same base, that is BC. And what this is, A and D are on the same side of BC, okay? And if AD is extended to intersect BC at P, we have to show these four things, alright? So if these two triangles are on the same base and both of them are isosceles triangles, so we can say that side AB is equals to side AC. Also side BD will be equals to side CD, just because they are isosceles triangles. So we need to first prove that triangle ABD is congruent to triangle ACD, right? So we need to prove this triangle is congruent to this triangle. So first of all we can see that this side AB is equals to side AC, that is given in the question. Side AD is common in both these two triangles, and side BD is equals to side CD, because triangle BDC is also an isosceles triangle. So by SSS congruency we can say that triangle ABD is congruent to triangle ACD. Second part that we have to prove is triangle ABP, the bigger triangle, is congruent to triangle ACP, right? So in this we can see that side side AB is equals to side AC. The side AP is common in both, and by CPCT we can say that this angle is equals to this angle. Just because triangle ABD is congruent to triangle ACD, we can say that angle PAD is equals to angle CAD by CPCT. So clearly we can see that these triangles ABP and ACP is congruent by side angle side congruency criteria, right? Side AB is equals to side AC, angle BAD is equals to angle CAD, and the side AP is common in both. So by SAS congruency criteria we can say that these two triangles are also congruent. Right, next thing we have to prove that this line AP bisects angle A as well as angle D. So we have seen that if this triangle and this triangle are, these two triangles are congruent, then we can say that this angle will be equal to this angle. First thing is this. Second thing, we can also say that if this triangle is congruent to this triangle, then we can also say this, that this angle will be equal to this angle, right? Now for, if we need to show that this line AP bisects angle A and D, first we will see that if it bisects angle A or not. Clearly we can see that if these two angles were equal, because this we proved earlier by CPCT that these two triangles are equal, so we can say that line AP bisects angle A. Now for, if we need to prove that line AP also bisects angle D, we will first prove the congruency of triangle BPD and CPD, right? For their congruency, we can see that this side is equals to this side, this is common side, and this one is right angle triangle, right? Or right, these two angles are also equal. So by RHS congruency we can say that these two triangles are also congruent, and if these two triangles are congruent, we can clearly say that this angle will be equals to this angle. So if these two angles are also equal, we can clearly say that this line AP bisects angle D also, right? For if we need to prove that this AP is the perpendicular bisector of BC. So now if we need to prove that this AP is perpendicular bisector of BC, we can we have proved that this triangle is congruent to this triangle. So we can say that by CPCT this side will be equals to this side, right? Side BP is equals to side PC. And in the first example we have proved that why angle APB is equals to angle APC, and which were equal to 90 degree. So we can say that side line AP is perpendicular bisector of BC. So the remaining questions are also same. By you will be needing all those 5 congruency criterias in this question, in these remaining 4 questions. So just complete exercise 7.3. In the next lecture we will be discussing the remaining inequalities in triangle. What will happen if two triangles or two sides or any sides of any triangles are unequal? Is there any relationship that we can reduce? So this thing we will see in the next class. Till then, complete exercise 7.3.